Welcome to Module 2, 10.1 Percentages. We're in financial mathematics, so we'll be using percentages in the terms of financial math. So as a consumer, you make decisions about money every single day. Minor ones, should I get gas at this station where it's 5 cents cheaper? Or other more significant ones. If I buy that brand new red Mustang, should I take the dealer rebate or should I take 0% financing? So this section is going to hopefully answer those questions as well as the sections to come in this entire module. So there's common sense and arithmetic for quick decisions. On a 20-gallon fill-up, you're saving $1 for 5 cents. 5 cents times 20 gallons is going to be $1. But the second question requires a lot more understanding of the time value of money. Is $2,000 upfront worth more or less than saving the interest on payments over the next 5 years? And if your head just kind of blew up because it's just way too much, that's usually what ends up happening. And a lot of times we don't make smart financial decisions because the mathematics of it can feel really daunting. So you don't like fractions because I don't think I've ever had a student that likes fractions. So you don't like fractions, but we are going to talk about fractions. And usually the issue comes from a different denominator or the bottom of the fraction. So one way to get around this difficulty is to express fractions using a common standard denominator, and that denominator is 100. So when we talk about percentages and the relationship with fractions, is a fraction with the denominator of 100 is a percentage. The symbol percent indicates that hidden denominator of 100. So let's see. Show you kind of what I mean here. If we have 20%, what we're really saying is 20 over 100. So once it's a fraction, you don't use the percentage symbol anymore, and only the top value actually becomes the percentage. So percentages are useful. We use them all the time. It might rain, 50% chance of rain today. They're common comparisons, 15%, 20% tip, taxes. We use to discuss the relative baseline and things like that. So this is really important. In mathematics, we do not multiply percentages with numbers. So we would never actually take 20% and times it by anything. We would never do that. We would actually change that percent to a decimal and then multiply, or a fraction. Remember that that's the same as 20 over 100. We can multiply that. Or that's the same as if we have a percent, we can move the decimal to this way and it becomes 0.20. So we're going to go into that a little bit more. So decimals and percents. Decimals can be converted to percentages by multiplying by 100. Or what's really common is that people like to think, okay, multiplying by 100, that's 2 zeros to the right. So that's 2 this way. So even if you've got something like this, this would be 0.5%. Now we can go the other way. Percentages going back to decimals, we want to divide by 100, and division means make smaller, so we're going to move in that direction. So we could take the percent, we've got 83.2%. We could divide 83.2 by 100, or we can move the decimal back in this direction. So that's a couple different ways to deal with percentage and decimal conversions. Suppose that in your literature class you scored 19 out of 25 on the quiz, 49.2 out of 60 on the midterm, and 124.8 out of 150. It's really hard to tell your best score because we're basically dealing with different denominators here. So these are our raw scores, but to compare them, we're going to turn them into percentages. So if we have 19 out of 25, grab your calculator and do 19 divided by 25, and that gives us our percentage of 76. And so if you do that with all three, you can see that the final exam was your best score. So I'd pause and practice working with those decimals and percentages. Imagine you take an old friend out to dinner and they're a little strange, so they say they want to tip 3/20ths of the bill. You don't know what that means because no one talks like that. So one thing you can do is convert that fraction into a percentage. So we know that 3/20 is the same as saying 3 divided by 20. When we do that in our calculator, we get 0.15, and we can move the decimal twice, and we get 15%. So remember, to compute the actual tip, You're going to take that number, that percentage value as a decimal, multiply by the total, and that'll give you your actual tip. So let's say you are shopping for an iPod. Imagine you decide to buy yourself the latest iPod, which I don't know, textbook, do they make iPods anymore? Okay, you can buy the iPod and the price is $3.99, but then they've got sales tax. So how do you figure that out? Well, the sales tax is the amount multiplied by the total. It's a percentage of that total, but you have to add it to the original amount. So what we're trying to do here is we need to actually get this percent to a decimal. So we've got 6.75%. To change it to a decimal, we go 1, 2. So it's going to be 0.0675 times that amount, and that's how you can calculate the total cost. Now, that's a shortcut. So we can shortcut this by saying the original price is 100% plus the sales tax is 6.75%. So that's a total of this amount of percentage of the original. And this is really important here. Of means multiply. So we could just do a really simple calculation of 1.067 times $3.99 and get the exact amount. Okay, let's say you're comparing now. There's another electronics store, it's $4.15, but you have a 5% off coupon. So how does that work? So if you have 5% off, another way to think about it is you're only going to pay 95% of the price, right? Remember that of means multiply, so you're going to turn that to a decimal, multiply it by the price, and then of course we can't forget the tax. So we still have to add that 6.75% tax onto that amount. So now we're paying the whole amount of the $3.94 plus that additional tax, and it comes out to be $420. Now, let's say you found it online, which is more likely, and someone's going to sell it for $441. There's no tax, but you've got shipping this time. You wouldn't have to pay if you picked it up at the store. So if you can pick it up and save the 5%, what would your cost then be? So again, these are real decisions you make in your life. Do you want to pay the shipping or do you want to pay the tax? How do you want to do that? So it's the same thing we're looking at, $441. We're not going to take the 5% discount because it was added to the base price to come up with that final price. So that's saying that the final price is 105% of the base price. So if 105 is the base, we want to know, okay, what if we were to take off that 5%? We know it's 1.05, right? 1.05 times the price that we don't know what it is. And we know that the final price they came up with $441. So we're going to divide both sides by 1.05. And we find out that, okay, they're actually, if I pick it up, the iPod is only going to be $420. So we've got option 1 with the tax. It seems like a better deal because it's $3.99, but we've got the tax. We've got the 5% coupon and the tax. And then we've got the $420 without tax. And if a friend picks it up, we get to take out that 5%. So although option 3 is the cheapest, maybe it's not the best idea for those pennies, right, to send a friend to pick it up. Maybe the best bet is actually this. Now, again, later we're going to be talking about choices in a later module, and maybe you'll say like, no, I'm going to make my friend pick it up for 86 cents saving. That's a choice you can make and go from there. So one thing we can talk about is percent increase. If you start with a quantity and let's say it increases by 20%, how do you figure it out? This is the formula for that. And a percent decrease, this is the formula for that. So this is another way to look at the exact same formula, but just a little bit different. So let's look at a stock market. The stock market is one stock market we use a lot is Dow Jones. Okay, so as of the writing of this material, which was in 2014, so that's pretty old, the Dow Jones was around 13,000. We're going to illustrate the ups and downs using just completely fictitious numbers. So on a particular day, the Dow closed at 12,875, and then on day 2, it closed at this number. It's an increase of this amount from the previous day. We got that number by just subtracting. But the increase as a percent, we're trying to figure out, okay, 154.5 is what percent of that baseline of what it started with. How much did it grow? What percentage did it grow? So this is a formula I really like to use. Is over of equals percent. So basically, you have to find out what the is. So 154 is what percent of. So we put it's is over of. So that's how we got the 154.5 over 12,875 is equal to that. We move it over twice, and we get a 1.2% increase. Percentage decreases are often used incorrectly in an effort to exaggerate or mislead. So the misuse is usually framed by the claim that if an X percent increases changes A to B, then a decrease will change a B to A. That's not true. They're not inverted in that capacity. Let's see. Oops, sorry. All right. With great fanfare, the police chief of Happyville reports a decrease by 200% in 1 year. He came up with this number based on reported crimes going down from 450 to 150. Since an increase from 150 to 450 is 200%, he or she, oh no, they said he, did assume that the decrease would also be a 200% decrease, but that's not quite right. They're not interchangeable. So let's take a look. If the baseline is 450, not 150, so the correct computation of the decrease would be 300 is the actual decrease. We did that by subtracting, divided by our baseline, which is the starting. It's a 66.67% decrease, which in terms of crime, I'd say is like a major win, but it's certainly not 200%. Okay, so you want to be really aware of these kind of extravagant claims about percent decreases. You'll see it a lot in the media around crimes and traffic accidents, pollution, or anything that's non-negative. Just keep in mind that percent decrease can never exceed 100%. So an important part of being a smart shopper is understanding how markups or profit margins and markdowns sales affect the price of consumer goods. So a toy store buys a certain toy from a distributor to sell during Christmas. The store marks up the price by 80%. That's the intended profit margin. They want to make 80%. But unfortunately for the toy store, it's just a total bust and it doesn't sell well. So after Christmas, it goes on sale for 40%. And then after a while, they just do another 25% markdown off of the sale price. So where does that leave the profit? What is the percentage profit loss to the toy store? So the answer to this question is independent of the original cost. We actually don't need to know the original cost. So let's just say the cost is C. After adding an 80% markup, they retail for 1.8. Remember that 1 represents 100% of the cost and then that 80%. Okay, so 100% of the original cost and then 80% on top is how they get that 1.8. After Christmas, they mark it down 40% off. Now, that means what you're actually going to be paying is 60% of that price. Now, we love that of because that means multiply. So now we've got this price here, but now the consumer is only paying 60% of it. So when you multiply 0.6 times 1.8, you end up with this amount here. So which represents a markup of 8% on the original cost. Not really making much money there. Finally, they keep going. The toys put on clearance with an additional 25% off. Now, if it's 25% off, that means it's 75%. So we have this original. This is that original markup and then the Christmas markdown. And this is what the consumer is going to pay left. Now we're left with 0.81 of the cost. When we lost that 1, that means we're not even breaking even. Remember, C is the cost. Point, a decimal, we're taking a decimal of that cost. So the clearance price is now 80% of the original cost. So now they're losing 19%. So in section 1.2, things are going to get a little more complicated because we're going to start talking about simple interest and time value of money.